This is a section on compound inequalities. We'll also get into writing values with interval notation rather than the x greater than and x less than notation. So I've got two statements here, and the question says, what is the difference between these two statements? The first one says x values greater than 6 or less than 3. The other one says x values greater than 3 and less than 6. So greater than 6 or less than 3, x values greater than 6 or x values less than 3, means that either one of them satisfies the answer. So if I were to look at these values on a number line, like let's say here's 3 and here's 6, x values greater than 6 would mean anything from 6 to the right. So greater than 6 from here to the right. Or less than 3. 3 and anything to the left, including negative numbers. So everything except for those values between 3 and 6. The second one says x values greater than 3 and less than 6. So greater than 3 and less than 6 means it has to satisfy both of them. So if I have a number line here, and I'll put 3 on there, I'll put 6 on there, I want greater than 3. So here's the ones that are greater than 3. Here's the ones that are less than 6. Where do they overlap? They overlap in that middle between 3 and 6. So for this one, our solution is all the values between 3 and 6. All right, so in that first case, if you had a number like 7, that works because it's either greater than 6 or it's less than 3. If you had a number like negative 2, it's less than 3, so that's fine. In the second case, it has to be both greater than 3 and less than 6. So a number like 4 will work. 4 is both greater than 3 and it's also less than 6. But a number like 7 will not work because even though it's greater than 3, it's not less than 6. Right? So we graphed each one on a number line to see what it looks like. We call these things compound inequalities because they're two inequalities, right? X is greater than 3 and x is less than 6 has two inequalities, x greater than 3, x less than 6. So to satisfy the and condition, it has to satisfy both inequalities. And that's why if you notice I graphed the two pieces separately and then said where do they overlap? They overlap between the 3 and the 6. This is kind of like what we were doing when we were shading stuff before back in chapter 4. We graphed one line, we graphed the other line, we shaded the two inequalities to see where they overlap. Same thing here, except we're graphing them with one variable on a number line. So to satisfy an or, you've got to satisfy at least one of the inequalities. If you satisfy both, that's fine, but satisfying one of them is a requirement. So outside of the value of x types of problems, sometimes you think of these in terms of like a graduation requirement. So if the graduation requirement was that you have to take a math class and an English class, if you just take one of those two, that's not going to satisfy a graduation requirement. But if the question said you need a math class or an English class to graduate, then if you take a math class, that satisfies the condition. If you take an English class, that satisfies the condition. So you don't have to take both, you have to take one or the other. So this one is just, will this work for a solution? So given this compound inequality, is x equals 4 a solution? So the question was x plus 2 is less than 7 and 2x minus 3 is greater than 3. So let's see if x equals 4 is a solution. So we'll put in a 4. Is 4 plus 2 less than 7? Yes. 6 is less than 7. So it works. How about the other one? 2x minus 3. So 2 times 4 minus 3. Is that greater than 3? Well, 2 times 4 is 8. Minus 3 is 5. So yes, in order to satisfy it, it has to satisfy both. So x equals 4 works. Hey, how about the second one? How about x equals negative 4? So try negative 4 plus 2. Is that less than 7? Well, negative 4 plus 2 is negative 2. Negative 2 is less than 7, so yes, it works. How about for the second one? 2 times negative 4 minus 3 is greater than 3, so negative 8 minus 3 is negative 11. No, negative 11 is not more than 3. Because it's an and condition, it has to satisfy both equations, so x equals negative 4 is not a solution. And why? Because it doesn't work in both inequalities. If it's an and situation, the solution has to work for both inequalities, and this one only works for one of them. So let's graph these on a number line. The first one says to graph x is greater than 6 or less than negative 2. The one on the bottom says to graph x is greater than 6 and less than negative 2. So first of all, let's set ourselves up a little number line here. I'll put negative 2 over here. I'll put 0 over here. And 6 over there. Now, the first one is an OR. So we have to satisfy one or the other, but it doesn't have to satisfy both. So x is greater than 6. We put an open circle on 6 and shade to the right. So I'm used to doing open circles, although I'll show you how the book does it in a minute. Open circle means we do not include the 6. If this had been greater than or equal to 6, then we would put a closed circle to include it, but we don't. All right, the other possibility is x is less than negative 2. So we put an open circle on negative 2, shade left. Okay, so that's x is greater than 6 or x is less than negative 2. The second question says graph x is less than 5 and x is greater than or equal to 3. Let's set ourselves up a number line because then the second question asks something about a three-part inequality, which will make more sense after we graph this. So let's put a 3 on here because we're going to need that. And let's put a 5 on there because we'll need that. X is less than 5 starts here and works to the left, right? Less than 5. Greater than or equal to 3 starts here at 3 and works to the right. So when I write my final answer is where do they overlap because this says and. So it includes the 3. It puts an open circle on the 5 and includes everything in between. So my final answer was what's there on that number line. The work on the top was just my scratch work to get less than 5 and greater than or equal to 3. So can I write this as a three-part inequality? Look at what I have shaded there in purple. I have all of the x values are between 3 and 5, not including the 5, but including the 3. And so that's how I can write it as a three-part inequality. That's a combination saying that x is both greater than or equal to 3 and less than 5. Hey, for the third one, it says graph x is greater than 6 and less than negative 2. Go back to my drawing that I have up on the top here. Right? This was the graph that I had for the OR. If it says and, then that means it has to satisfy both conditions. So I have to find numbers that are both greater than 6 and less than negative 2. Well, you can see if I graph the inequalities up at the top, where is the overlap between them? There's no overlap between them. There's no numbers that are both bigger than 6 and also smaller than negative 2. So if I have to graph this one, it's just an empty number line. There's no solution. There are no numbers that are both greater than 6 and less than negative 2. Now, rather than open and close circles, the book uses a little bit different notation. So let's look at interval notation because really that's the type of notation that they're using on the number line. So suppose they had a set of values like x is greater than or equal to 3 and less than 7. Instead of using open circle, closed circle, when we write interval notations, what we do is use a bracket if it includes the point and a set of parentheses if it doesn't include the point. So if it's greater than or equal to, less than or equal to, then we use the bracket. If not, then we use the parentheses. So how do we write this using interval notation? Well, here's what we do. We say we're going on the interval from 3 to 7. And we look here, this says include that 3, so we put a nice bracket around the 3. Over here it says don't include the 7, but get as close as you can to it. So we include an open set of parentheses. So that's what we call interval notation. We go from 3 to 7, including the 3, but not including the 7. Most of the times when we write domains and ranges, especially for higher level courses, we don't write it as x greater than or equal to 3 and less than 7. We write it with this interval notation because it's a more compact notation to set this up. So let's take a look at the first one. The first one says x values from -1 to 3, not including the -1, right, because it says strictly greater than, but including the 3. So don't include the -1, so we'll put a set of parentheses there. Include the 3, so we put the bracket. For the second one, it says x is greater than or equal to 2. So before we go to put this in interval notation, let's see what it looks like on a number line. If we go to graph this on a number line, if this is 2 right over here, greater than or equal to 2 is every value from 2 to the right of 2. Now, how do I write that in interval notation? Well, we're including the 2, and then we're going to the right as far as possible. How far? Well, infinitely far. Infinity always gets an open bracket, doesn't get a closed bracket. So from 2 to infinity, we include the 2. We never include the infinity or negative infinity. So that's how I write that second expression, x greater than or equal to 2, on a number line. The third one, x is less than 0. Well, if this is my number line, here is 0, we want values that are 0 or less, but not including the 0. So not including the 0, and we shade left. Well, how do I write that on a number line? Where does the graph start on the left side? It goes all the way to negative infinity. How far up does it go? It goes to 0, but not including 0. From negative infinity to 0, that is my interval. So that's the equivalent of x is less than 0. Starts as far to the left as possible, which is negative infinity, and then goes up to 0, but doesn't include the 0. All right, this is the reverse. This is right as a compound inequality. So now I'm giving it to you in interval notation. I want you to write it as a compound inequality with x's. So maybe it's interesting to graph this and see what's happening. This says that my solutions go from negative infinity to -5. So they start as far to the left as possible. They go up to -5, but this bracket here says don't include the -5. So open circle on -5, shade left. What does that look like as a compound inequality? It's x values that are less than -5, but not including -5. Right, look at our second one. Our second one goes from -2 to infinity. So it starts at -2 and then goes as far to the right as possible. So here, let's say, is -2. Look at that bracket. That bracket says include the -2. Shade to the right as far as possible. So this is a greater than situation. Actually, it's a greater than or equal to. X is greater than or equal to -2. So we're including the -2 and every value to the right. The last one is kind of simple because it includes both endpoints. So we're going -3 up to and including 0. So you notice both of these had brackets, a bracket over here and a bracket over there. So that's why we say greater than or equal to -3 and less than or equal to 0. So why are we doing all this inequality stuff? Well, because the textbook, rather than open circle, closed circle, uses those parentheses and brackets on a number line. Generally, I don't, and until I started teaching from this book, I'd never seen a textbook that uses those types of parentheses instead of the open circle, closed circle, but it's good to see it in both ways. So I'll give you a little example on the next slide, which I took from the supplemental materials that came with the textbook. So you notice the question is, we're going to graph x is less than 7 and x is greater than -3. So if somebody said graph x is less than 7, all of my years of graphing would have said put an open circle on 7, shade to the left. But look what the textbook does. They put that open set of parentheses on the 7. Now on a test, I would certainly take the open circle. In fact, that's probably how my answer key is written. But if you put that little bracket there, that's fine too. You just have to get used to doing it when you do the online homework because it's going to look for that open parentheses at 7. The same thing for x is greater than -3. They put the open parentheses at -3 rather than the open circle and shade right. What if you want to combine them? What if you want x is less than 7 and x is greater than negative 3? Then you're going to look to see where they overlap. So they overlap from here to here. So when we graph the final answer, we put the open bracket on negative 3, we put the open bracket on 7, and then we shade in between. Right? And that's the solution to x is less than 7 and greater than negative 3. All right, so these questions say try these. In a class, we would probably all just break out into groups and try them. So maybe this is a good time to pull these up in the PowerPoint, try working through these examples, pause the video, and then when you're ready to check answers, I will have some answers on the other side for you, right? So if you want to pause, this is a good time to do that. Try these problems. We'll come back and verify. All right, so now that you've tried these problems, here's what I'm going to do to get the solution. This first one was an and, so it has to satisfy both conditions. X is greater than 3 and less than 8. So greater than 3 is from 3 to the right, less than 8 is from 8 to the left. So where do they overlap? They overlap between 3 and 8. And you notice the way it was set up, it doesn't include either of the endpoints. So it doesn't include the 3 or the 8. It includes only those values in between. So if you're graphing it by the textbook way, you would put an open parentheses there, open parentheses on the 8. I would say the answer is between 3 and 8. Now, just to point this out, we've been graphing so many ordered pairs that after a while, that 3, 8 begins to look like an ordered pair. So you have to realize that that's actually interval notation saying values that are both greater than 3 and less than 8. So always include the context of the problem. You wouldn't answer 3, 8 thinking it's an ordered pair here. We're not graphing anything. We're only graphing on a number line. The second one was x values that are greater than negative 5 and less than or equal to 2. So here's your negative 5. Here's your 2. Let's see what values make sense. Again, we're going to sort of do a little scratch work on the top and then combine our answers. So less or greater than negative 5 is this way. Less than or equal to 2 is that way. We want where they overlap. So I would put a closed circle here, open circle there. The textbook would put an open parentheses here, would graph the line, and then put a closed parentheses over there. If I'm going to write this in interval notation, I'm not going to include the negative 5 because it's strictly greater than. But when I get to the 2, I will put a closed bracket around that 2 to indicate that I'm including the 2. All right, the third one says greater than 1 or less than or equal to 0. So there is 0, there is 1. If I want greater than or equal to 1, that's this way. Less than or equal to 0 is that way. Or you could put the closed brackets like that. Closed bracket like that. So how do I write this in interval notation? Because it's really two sets of values. It's all the values from negative infinity to 0, and then all the values from 1 to infinity. So what I do is I write it in two parts. I say I want all the values from negative infinity to 0, including the 0, and then also all the values from 1 to infinity. So it becomes a union situation. You put that U in the middle to indicate that I want the first range of values and then also the second set of values, the values from negative infinity to 0. Add to it the values from 1 to infinity. All right, less than 4 or greater than 13 halves. 13 halves is the same thing as 6.5, right? 12 halves would be 6, so 13 halves would be 6.5. What happens over here? Nothing terribly shocking. Less than 4 or greater than 6.5. Here, let me write this the way the textbook would, with its open circle, closed circle stuff. Less than 4, we would write with that open bracket that way. Greater than 13 halves, we would write with that open bracket that way. So in terms of interval notation, it goes from negative infinity to 4, doesn't include the 4, add to it all the values from 13 halves to infinity. All right, maybe a couple of special cases here. The first one is just an and situation. X's that are greater than or equal to -2 and less than or equal to 5. Those are the values that go from -2 to 5, including both the endpoints. For the next one, less than -4 or greater than +3. So let's see what happens here. There's -4. There's +3. So yeah, we've seen this one a couple of times. Less than or equal to -4 is a closed circle, shade left. Greater than or equal to 3, closed circle, shade right. So these values go from -infinity to -4, and then again 3 to infinity. Right? And we don't include the infinities as closed brackets, only open brackets. Hey, look at that last one here. Greater than or equal to 1 and less than or equal to 0. So here's 1, here's 0. Whatever I come up with has to satisfy both conditions in order to get me an answer. So greater than or equal to 1, less than or equal to 0. But wait a minute, there's no overlap. So what's my answer? What are the values that are both greater than or equal to 1 and less than or equal to 0? There are none. So there's no solution. The solution is actually something we call the empty set. And so I guess I could write a set that had nothing in it. Or I could write an interval that had nothing in it. But the real answer is that there's simply no solution. There's nothing that satisfies both of them. Or I could write a 0 with a slash through it. That's an empty set also. Right, and then the last part of this is solving compound inequalities. And then we'll do a little application at the end too. So yes, this video is going to go a little long. Solve 4x minus 1 is greater than 7, or 2x plus 4 is less than or equal to 2. I'm going to solve each of these separately. So I'm going to solve 4x minus 1 greater than 7. So I'll add a 1 to both sides. 4x is greater than 8. X is greater than 2. Right, so divide both sides by 4. I get x is greater than 2. The other equation was 2x plus 4 is less than or equal to 2. So I'm going to subtract a 4 from both sides. 2 minus 4 is -2. Divide by 2. And I get x is less than or equal to -1. Now, original question had an or. So I want x values that are greater than 2 or less than or equal to -1. Maybe a number line would help me to set up my interval notation more easily. Here's where 2 is. Here's where -1 is. Again, they don't have to work for both. They only have to work for one. That's an or situation. So greater than 2 is here and to the right. Less than or equal to -1 is here and to the left. So I want the values from -infinity to -1, including the -1. I also want the values from 2 to infinity. So we're not including the 2, so no bracket around the 2, just a parentheses around the 2. Open bracket around infinity, because infinity and -infinity always get open brackets. All right, let's try this. So we're going to solve each inequality separately and then see where they overlap. So 2x minus 7 greater than or equal to -1 and 3x minus 10 less than or equal to 5. So let's solve them separately and then see where they overlap. So here I'll add a 7 to both sides. 2x is greater than or equal to 6. So x is greater than or equal to 3. Over here, add a 10 to both sides. And I get 3x is less than or equal to 15. So x is less than or equal to 5. Right, let's see where things overlap. Graph it on a number line. That'll help me. So the x values that are greater than or equal to 3. So I'm going to do a little scratch work to see if I can find where they overlap. So greater than or equal to 3 works from here to the right. Less than or equal to 5 works from here to the left. So they overlap between 3 and 5, including the 3 and including the 5. So when I graph it on a number line, I want to see where they overlap. They overlap between 3 and 5. Any value that you put in between 3 and 5, including the 3 and including the 5, will work in both equations. Anything that you put in that's smaller than 3 or larger than 5 won't work. And in fact, they might work in one of the equations, but not both. All right, let's take a look at the first one that's up here. We don't have to do both of them, but let's take a look at the first one, because we might come up with something interesting. 4x plus 5 is less than 1, or 2x minus 1 greater than negative 9. So first step is we're going to solve these like we've solved every other inequality so far this semester. We get 4x less than negative 4. When we divide through by 4, negative 4 divided by 4 is negative 1. So we get x is less than negative 1. Over here, if we add a 1 to both sides, we get 2x is greater than negative 8. Divide through by 2, and we get x is greater than negative 4. So less than negative 1 or greater than negative 4. Negative 4, remember, is down here. Negative 1 is up here. 0 is over there. Let's plot these. Less than negative 1 is here and shade left. Greater than negative 4 is here and shade right. When I get done, the entire number line is covered because it's an OR situation. So every number is either bigger than negative 4 or less than negative 1. So the answer is all real numbers. Question is, how do I say all real numbers with interval notation? Well, it's everything from negative infinity all the way to positive infinity. So that's how I write all real numbers on a number in terms of interval notation. It's everything. Every number from the far left to the far right is included here. All right, sometimes these compound inequalities will be given to us as a compound inequality. So rather than writing 2x plus 6 is greater than or equal to negative 2 and 2x plus 6 is less than or equal to 8, we might write it this way. So we can solve these compound inequalities rather than separating them, keep them together, and perform the operation on all three pieces. So you notice I've got a 2x plus 6. I'm trying to solve for this x that's over here. So in order to do that, I've got to do two things. The first thing is get rid of the 6. If the 6 is being added, we undo it with subtraction. But we undo it with subtraction in all three parts. Let's move my work up to the top. Negative 2 minus 6 is negative 8. The 6's go away in the middle. And on the right side, 8 minus 6 is 2. Now we divide everything through by 2. Negative 8 divided by 2 is negative 4. 2x divided by 2 is x. 2 divided by 2 is 1. The nice thing about solving it this way is I've got my answer in interval notation already set up. Include the negative 4, include the 1. So putting values in between negative 4 and positive 1 will work. Try 0. 0 is the easiest one. If you put a 0 in for x into the original inequality that I had there, you're going to get negative 2 less than or equal to, well, 2 times 0 is just 0, plus 6. And sure enough, 6 is both greater than negative 2 and less than 8. Works. All right, let's try solving this one down the bottom. If I'm going to solve for x, I'm going to start by adding a 1 to both sides and that side. So all three pieces get a 1. Negative 1 plus 1 is 0. Negative 1 plus 1 zeroes out, so I just get 2x. 3 plus 1 is 4. Last step is to divide everything through by 2. Well, when I do that, 0 divided by 2 is 0. 2x divided by 2 is just x. 4 divided by 2 is 2. Write this in interval notation. Well, don't include the 0, include the 2. All right, and this is the last example of a rather long video, but here we go. A rectangle is 3 times as long as it is wide. If the perimeter ranges from 100 to 160 inches, what values for its widths are possible? So it says the perimeter ranges from 100 to 160. So the perimeter ranges from 100 to 160, meaning I can include the 100 and I can include the 160. It also says that it's 3 times as long as it is wide. So if I had a rectangle that looked like this, if that's how wide it is, that's how long it is. And remember, the perimeter includes the other 2 sides also. So it includes that side and that side. So the perimeter is W plus 3W plus W plus 3W. It's 8W. So come over here and replace that P with an 8W. So 100 is less than or equal to 8W is less than or equal to 160. And my last step then is divide everything through by 8. 100 divided by 8. Well, I can knock a 4 out of top and bottom. I'll get 25 halves. 16 divided by 8 is 2, so that's 20. 25 halves is 12 and a half. So the possible values for the width is that they are between 12 and a half and 20. So if you were trying to fence in a rectangular area and you wanted a perimeter somewhere between 100 and 160, maybe you needed at least 100, but you didn't have any more than 160 inches of fence, or maybe even feet of fence if you were fencing in a garden or something, then your width could be between 12 and a half and 20, and it would still satisfy that inequality. All right, and that is the end of compound inequalities.